Hi everyone, my name is Hallie Arnett. For my presentation, I will be talking about supernovas. Supernovas, by definition, are the explosion of a star. They are, in fact, the largest explosion that takes place in space. Personally, I think supernovas are beautiful and awe-inspiring and overall just super cool. And it's been super cool to learn about them. Supernovas are stars going out in style. The life of a star before it progresses to a supernova is as follows. The star is created from a molecular cloud and progresses from a protostar to an ordinary massive star. To put things in perspective, massive stars are larger than 8 solar masses. It is 8 times bigger than the sun. That's pretty incomprehensible to me, at least. Then the star progresses on to a yellow supergiant, then a red supergiant as its surface begins to cool down. And finally, it explodes into a beautiful supernova. To dive deeper into the chemistry of massive stars, they have many, many shells of elements that slowly go into an iron core. Each shell is created through nuclear fission, as each newly made heavier element goes through nuclear fission to end with creating the iron core. However, after the iron core is created, the star can't create heavier elements. This causes it to go bigger into a supergiant as it continues to create those elements that it already has, including hydrogen, and eventually collapse in on itself from its own gravity and explode into a supernova. So, what do supernovas tell us? Why are they important? Because of supernovas, scientists have been able to identify what the universe's expansion rate is. They do this by studying how long it takes for a supernova to expand over time. In addition, supernovas have been identified as the original source for elements heavier than iron. Not only do they create new elements, they also distribute elements across the galaxy, getting them further faster than they would have if they had tried to get there without a big explosion. There we go. There are two kinds of supernovas we have identified. Type 1a occurs in binary star systems, meaning there are two stars orbiting each other and coming closer to each other. One of the stars begins accreting the matter from its companion, causing the star to reach the end of its shell life much faster. Type 2 is the more basic type, where the star begins to reach the end of its lifetime, collapses in on itself, and becomes a supernova. Recently, astronomers watched a star develop into a supernova for the first time. They watched the star for its final 130 days before it exploded. They studied the final moments of a red supergiant star. They watched using the Keck Observatory's Low Resolution Imaging Spectrometer, or LRIS, to capture the supernova's first spectrum. What it captured was circumstellar material around the star before it exploded and during the supernova itself. Astronomers said it was like watching a ticking time bomb. We've never confirmed such violent energy in a dying red supergiant star where we see it produce such a luminous emission, then collapse and combust until now. What the astronomers learned from this play-by-play of a star's death is that stars eject material prior to the core's collapse. In addition, the star emits a bright flash prior to the star's explosion, which is likely related to the circumstellar material it was ejecting prior. However, they haven't figured out how they all interact yet. Okay, now for some random fun facts that I found while researching for this presentation that I wanted to include. A supernova occurs every 10 seconds in the universe and every 50 years in the Milky Way galaxy. If only we were able to capture all those supernovas throughout the universe, we'd have plenty of data in no time. Also, I don't know if any of you guys watch the DC TV shows like The Flash, but I just had to include this. Supernovas are cosmic particle accelerators and have been replicated in the lab at the DOE, the Department of Energy. They have also been shown on TV shows like The Flash. So basically, they are trying to create a mini supernova in the lab. No wonder it blew up in The Flash like it did. In summary, supernovas are explosions of massive stars when they become too heavy to support themselves. There are two types of supernovas, one where the star dies naturally and one where the star's death is accelerated by combining with another star. Supernovas help create and distribute elements in the universe, and we were able to learn new things about supernovas by watching one for the first time. And supernovas are so cool. We've tried to make them here on Earth. And here are my references. And thank you so much for watching.